Welcome everybody. Those in the club room and those on Zoom, you're welcome wherever you may be sat. Certainly the ones in Spain, you do well to be in the club room. So I need to thank Michael Poxon for stepping in tonight after one of our South African colleagues unfortunately had to let us down, but he'll be performing later on in the year, I hope anyway. So, Michael Poxon. He's been interested in astronomy since about the age of 5, even though his degree is in linguistics, and especially variable stars. He independently discovered Nova Cygni 1975 while doing his A-levels, being a member of the AAVSO, which is the American Association of Variable Star Observers, an amateur professional body affiliated to Harvard University. His special interest is in young variable stars, and he runs the Young Stellar Objects section at AAVSO, and in 2002 he was awarded a NASA grant to participate in an astrophysics conference on the big island of Hawaii, and has written a book on astronomy with binoculars. So can everybody please put their hands together and welcome Michael Poxon. Thank you.
Oh, thank you. Yeah, thank you for the hands. Yeah, this is a bit of a departure for me because most of my talks tend to be sort of slightly astrophysical, I suppose. But this one is more it's more informal. There's lots of little stories and anecdotes. I'll probably go off on a few tangents. But yeah, as Steve said, my degree is in linguistics, so I've always been interested in words and names and things like that. I've actually sort of noticed that if you point stars up to people, the question they nearly always ask you is, how do you know what it's called? Which to me is silly. I mean, you know, how do you know what your friends' names are? You know, you just know what they, you know, someone had to give your friend a name, you know, when he was born. So by the same token, you know, someone in the distant past had to name a given star, like Sirius. So, you know, that's where the stars get their names from. I want to kind of start off there, way back in ancient times, and kind of end by coming right up to the present. So I'll just share my screen now. Share the screen. That's probably it. Is that it? Ah, there we go. Can you all see Orion fighting Taurus?
Yes.
We're okay? Right. To begin with, obviously, if we go back thousands of years to the times of the ancient Greeks and possibly even earlier, people really needed to know about the stars and, you know, what they did, sort of how to recognize them. And of course, one way of recognizing stars is to give them names. So obviously, certain stars appear to form very obvious patterns because human beings are very good at making patterns out of things. And a really good example is obviously Orion. Down here, you've got three bright stars that are an equally spaced line with a bright star above it and another bright star the same distance below it. So, you know, that's an obvious pattern. And of course, you've got another bright star down here, which is Kappa Orion. It's just kind of off the picture. But it's a very distinctive shape, like a sort of a, you know, a bit like the bow tie still on end, I suppose. But it's vaguely the shape of a person as well, especially if you see the 3 stars of the belt, which of course we all do. Obviously, to begin with, before people started really kind of giving names for anything, they would just, you know, sort of point at one and say, you know, they would think, oh, that bright one up there, that's, you know, that's red or something. But eventually, obviously, when people began to do things like sail the seas, journey across the deserts and so on, you really needed to know about the stars. You sort of needed to know when they appeared, if anything special happened when they appeared. So there we have the connection with things like weather. For instance, the Hyades, the actual word Hyades is Greek, and it means rainy. And it means that because when the Hyades rose just before the sun rose, the Greeks thought that's when the sort of rainy season began, hence the name. That's where they got the name from. In the same area of the sky, we've got Aldebaran. Aldebaran, like the vast majority of the star names, is Arabic in origin, and it means the follower. And it means the follower because it follows the Pleiades across the sky. First the Pleiades rise, and then Aldebaran a little bit later follows on. I mean, we kind of think of it as being the eye of Taurus, I suppose. You know, if you insist on making pictures, which I've kind of done there. So yeah, you needed to know that when the Hyades rose just before the sun, that's when you need to sort of batten down the hatches a bit on your boat, because the chances are it was going to rain quite a lot. And of course, the Greeks were great sailors. But Steve said earlier, I've been to Hawaii actually several times now, so I've kind of got an interest in Polynesian culture as well. And of course, they named the stars. They were even better sailors than the Greeks. Really, all the Greeks had to do was to sail from one island about sort of 20, 30 miles to the next one. But the Polynesians had to cross the Pacific, sometimes for hundreds of miles without land. So they really needed to know their stars. Something you may not know has to do with sort of celestial geometry, I suppose, is that your latitude is equal to the declination of the overhead point. So say, for instance, from our latitude of about 52 degrees, any star with a declination, that is its distance above the sky's equator, any star with a declination of 52 degrees will be overhead. So that's a nice, easy bit of basic maths, sort of astronomical maths to kind of remember. So from the big island of Hawaii, which is about 19 degrees north of the Earth's equator, that means that any star with a declination of 19 degrees will be directly overhead. And lo and behold, Arcturus has a declination of about 19 degrees, and of course it's very bright. And it was very important to the Hawaiians, and they call it Hokulea, which means star of hope, because if you're sailing the Pacific and you're not 100% sure where you are, all you have to do is follow that star, and as soon as you see it overhead, you know you're nearly home. Very, very important. But the Hawaiians actually came from Tahiti originally, and that's quite convenient because Tahiti is about 60 degrees south of the equator. And something else that's about 16 degrees south, this time of the sky equator, is Sirius. That means that from Tahiti, Sirius would be directly overhead. So to get from one island to another, you set out from Tahiti with Sirius overhead, and you sail towards Arcturus if you want to get to Hawaii. And you keep sailing until that star gets higher and higher in the sky. When it's overhead, you've got to Hawaii. Congratulations. I've just made a little note at the bottom of this page here that sometimes astrology, because we've got to remember that thousands of years ago, astrology and astronomy were essentially the same thing. They weren't differentiated as they are now. So some stars were given kind of astrological names. For instance, the three bright stars in Aquarius all mean lucky star of something or other. The Alpha Aquarii, its proper name is Sad al-Melik, and that means lucky star of the king. So star names can come from all sorts of directions. But we have constellations to look at as well. Now, there's a really good story here. This picture you can see is from a star atlas printed in 1822 by one Alexander Jameson. Yeah, I mean, to begin with, they weren't so much scientific sort of documents as works of art. As you can see here, it's a beautiful thing. The probably the original here was Johann Bayer's Atlas of 1603. That was famous because that was the first time that Greek letters were used to name stars. Basically, the way it works is the brightest star in a given constellation is called Alpha. That's the first letter of the Greek alphabet. The second brightest star is given the second letter of the Greek alphabet, which is Beta. That goes all the way through to Omega, which gives you 24 stars, because there are 24 letters in the Greek alphabet. This particular star atlas, he dedicated it to the king. That's King George IV. That's not Elvis. Elvis hadn't been born. And really, the way this worked is Jameson concentrated on certain areas of the sky. The main constellations in those areas were sort of painted in, as you can see here. Now, I actually owned a copy of this at one time because where I grew up, which essentially was in the same road that Sean Reynolds grew up in. It was basically, to quote a cliche, it was a road of two halves. There was a sort of council half, which is where the poor folks like us live, and there was a slightly posher half. And in the slightly posher half of the road was this bloke, and I think he must have been some sort of technical worker because he was really interested in science. I had a feeling he probably worked for the sort of telecoms as some sort of technical person. And he knew that I was interested in astronomy. I was only about 9 or 10. And he gave me a copy of this book, this 1822 book. And I looked at it and I saw all those beautiful pictures and how they were all being painted. And I thought, oh, you know, I was 10 years old. I thought, oh, I think I'll colour some of the pictures in as well. So I did. And a few years later, after I'd sold the book for about 75p, I think, I discovered a copy of this book had been sold for £900. So a bit of a salutary lesson there. If you've got kids and you've got valuable astronomical documents, keep them out of the way of your kids so they don't ruin them. Something else it's worth noting on here is if you can just see these kind of wavy dotted lines, they outline the boundaries of the constellations. Basically, you made up your own boundaries and you made up your own constellations. In fact, this constellation here, the Owl, Noctua, was invented by Mr. Jameson himself, who designed the atlas. But the actual the boundaries of the constellations weren't drawn up until 1930. So up until then, you know, you just had these kind of curvy line boundaries, which are all very well, but it's very hard to keep, you know, stars in one as distinct from a neighbouring one. But yes, I mean, at the base of all these types of sort of fine art astronomical atlases were, you know, was Bayer's one of 1603. Basically, everyone followed his dictates. But it's not just a work of art, you know, because the stars are marked, they have their names, they have their Greek letter constellations have their names and so on. And you know, you've got lines, you've got the equator, you've got the ecliptic here. So it's kind of science and art, really. Now, the Greek letter system, as I say, is all very well, but what do you do when you've got more than 24 stars in a constellation and you run out of Greek letters? Well, to give them other letters and numbers and all sorts of things like that. So let's have a look at this. This is actually quite a famous star catalogue. It's called Flansteins Catalogue, but it shouldn't be called Flansteins Catalogue. It should be called Lalonde's Catalogue, but he was the man that actually gave numbers to stars. And the way this works was in each constellation, you start from the west, or the right-hand side, if you like, and the most westerly star in your constellation is numbered 1. The second most westerly is number 2, and so on and so on. Now, this is obviously a brilliant system because you can't run out of numbers. But when Lalonde drew up this catalogue, he used sort of Flamsteed's findings, and as you can see here, he's used Tycho's as well. So he's kind of gathered together previous observers. Now, obviously, everything here is in Latin, and one great advantage of having a degree in linguistics is you know quite a bit of Latin. So he's also described where the stars are. For instance, if we look at, we've got some of the numbers here, and here we've got the Greek letters. If we look at this one, which is Gamma, that's Gamma. The constellation is Aries, by the way. These are the stars in Aries. Anyone who knows anything about observational astronomy will know that Gamma Arietis is a very famous double star. But I'm not quite sure if they even knew that in those days. And he's telling you where it is. It says which is the one of the two horns that is preceding. So it's, you know, it's in one of the horns of the ram. For those people that have one of those pictorial star houses, he's describing where it is. And it's number 5 according to Flansteins numbering. So it's a 5th star from the right in Aries. And as you can see, these numbers go all the way down, but he's got them in numeral order, which is very, very sensible. That's quite sort of scientific. And also here in the last column, he gives you the magnitude. So he tells us that Gamma Arietis is 4th magnitude, which indeed it is. So it's, you know, it's quite accurate. He's also given the position. What he's doing here, he's given the position in degrees, minutes and seconds, not hours, minutes and seconds, as we do now in right ascension. And instead of giving the declination, that is the star's distance above the sky's equator, he's giving the distance from the North Pole. But obviously, you know, it works out the same, but that's how they did things then. So this is the first, I suppose, what you call scientific star catalogue. And the great thing about Lalande is he also invented constellations, most of them in the southern hemisphere, and quite a lot of them still there. Unlike the poor old owl, which is, you know, it's flown off from the globe of the sky. So there we have Mr. Flanstein. But we need to use other systems as well, because when people catalogue the stars in the far south, for some reason, for some silly reason, they didn't use numbers. So when they ran out of Greek letters in southern constellations like Puppis that we've got here, which it's basically underneath Sirius, they used letters, you know, the normal alphabet, and they started with small letters. So, for instance, you know, you've got a Y and Z and F and A and B and so on. But even that wasn't enough. So after they got to their small Z, which is there, they started again, but this time they started with capital letters. And this time they did have enough capital letters. In fact, they ran out of capital letters at Q. Now that comes in very handy in the near future. When we'll have a look at how you made variable stars, because that was actually the original sort of motivation behind the entire talk. So yes, we've got small letters up to Z, and then we've got the big letters in the south, as it is, not in the northern constellations, that ran up to Q. So you've got capital A and capital F and capital E and so on. That's all in Puppis. And of course, it isn't just the normal stars that you can see with the naked eye that people started cataloguing. They also made catalogues of things like double stars. And there are several catalogues of these, which is why you get all these strange names here. Like you've got capital Delta there, capital Delta 38. Now that tells you that double star came from a catalogue by an observer called Dunlop. And because the D had already been used for some other reason, they just used the Greek version of a capital D, which is a capital Delta. So any star that's got this capital Delta in front of it, that means it's a double star from this man Dunlop's catalogue. And simply with this one, Beta 757, the beta stands for an observer called S.W. Burnham. He had a very interesting life. He wasn't a professional astronomer, but he didn't start off being a professional astronomer. He was a court reporter in Chicago in probably in about the turn of the 20th century, I think. Chicago being what it was then, he probably had quite a lot of work on his hands, being a court reporter. So yes, you have all these constellations, all these catalogues. Probably the most famous one was drawn up by a father and son team of Otto and Wilhelm Struve, who lived at what is now Estonia. So they didn't go very far south, but any double star, and again, because their initial S had already been used for something else, they did the Greek thing and gave it a capital sigma. So especially lots of northern double stars have these capital sigma designations. We'll look at one in a moment. This particular picture here is from my 1966 version of Norton Star Atlas, which, well, you know, you can see I've put loads of stuff on it. I've put loads of variable stars and double stars and all sorts of stuff. Even though most of the stuff is, you know, is too far south for we see, I just put it there because, you know, I wanted to make my mark on this Norton Star Atlas. But as Norton's came a bit more up to date, they did something that I think is rather silly. They got rid of all these designations that dated from the sort of 19th and early 20th century. Now, I think that was a silly thing to do, because if anyone has a copy of Norton's of whatever age, it consists basically of star maps, which you can see here, but facing the star maps are lists of interesting objects that are on that particular map. Now, as you can see, there are lots of double stars here, because what Norton's did was they indicated a double star by, you know, a dot with a horizontal line through it. You can see it here because it's a brighter star. And there are lots of these, there are lots of double stars. But because they've taken the names of these double stars away, they can't put them in the list of interesting objects because they haven't got names. So you can't say what they are. Now, that's very silly. I actually use my old version of Norton's to identify one of these, and it's one of these Struve double stars. It's Struve 2666. So you can then, you know, go to a book and you can look up Struve 266, you know, and you can get the details about it. But, you know, I did this, and it turns out that it's a double star, the magnitudes are magnitude 6 and 8, and they're 3 seconds apart. But Norton's won't tell you that because it hasn't named it, so it can't describe it anyway. Isn't that silly? Right, I now want to take you back to what we were saying about these southern constellations where they got up to capital Q and didn't feel the need to get any further. So we now, in the middle of the 19th century, going towards the start of the 20th century, have lots of variable stars. You probably wondered when we were going to get to variable stars, didn't you? Well, I shan't spend too much time, but it is complicated. So really what happened when these variable stars start to be discovered was they were thinking, well, you know, we can't give them Greek letters because, you know, the star changes in brightness. So, you know, one week it could be the alpha, it could be the brightest star in a given constellation. And, you know, a sort of a month or two later, you know, it could be the omega. So, yeah, so you can't give it a regular sort of name. And they realized that, they've used these capital letters in the south, but we only got as far as Q. So what we'll do is, when we discover a variable star, we'll call it R. So the first, for instance, is a picture of Cygnus. So the first variable star to be discovered in Cygnus that didn't have an already existing name was called R Cygni. And here it is, it's up here. It's right, it's in the same field as this bright star here, Theta Cygni. R Cygni is, at maximum, it's about magnitude 5, and at minimum, it's about magnitude 14. So it's very, very variable. And after they, you know, the next variable star to be discovered got the next letter of the alphabet. So that was S Cygni, which again is one of these long period pulsating stars, and it's right up here, right in the north of the constellation. And so on through to Z. That gives you 9 variable stars in each constellation. So after that, they start to discover even more because people are now using photography, and it's very easy to discover variable stars by photography. So after they got to Z, they thought, oh, what shall we do? We can't go back to the beginning alphabet because they've already done that in the southern hemisphere as far as Q. So what they decided to do is use double letters. So after Z, you go to RR, then RS, then RT, and so on through to RZ. When you get to RZ and someone has the bad misfortune to discover another variable star in that constellation, then you have to go back to the next letter, which is S. So you have SS. SS Cygni is a very, very famous variable star. It's up here, the star 75C. And then you go SS, ST, SE, all through to SZ. And then eventually you get right to the end of that double letter alphabet and ZZ. But of course, they discovered even more. So this time you still use double letters, but you go right back to the start of the actual alphabet. So then you go AA, AB, AC through to AZ. And you carry that on eventually until you get to QZ. And QZ means that's a 334th variable star in that constellation. But you've guessed it, they discovered even more. What shall we do now? We'll run out of letters. So they did probably what they should have done all along and gave them numbers. So after QZ Cygni was discovered, the next variable star in Cygnus was called V335 Cygni, and so on and so on and so on. So my nova in 1975 is actually called V1500 Cygni. Here it is up here, look. Nova 1975. That was the 1,500th variable star to be discovered in Cygnus. And we're now up to about V2,500 Cygni, I think. So lots and lots of variable stars. But isn't that a complicated way of naming something? Only variable star observers would be contrary enough to do that. So we're okay now, haven't we? We've got Greek letters, we've got small letters, we've got capital letters, we've got special letters for double stars, we've got special designations for variable stars. I haven't touched on nebulae because they're a different kettle of fish entirely. So we now, of course, have various astronomy surveys, various complicated surveys. I want to start off with this man called Friedrich Argento, mainly because he's called the father of variable star astronomy, but his main claim to fame is that he produced what's called a BD. He lived in Bonn, so he called it the Bonner Durchmusterung. Durchmusterung means a sort of a gathering together. So sort of catalogue is probably as good a translation as any. And it was brilliant because it not only had, as you can see here, this is a sort of a bit of the sky, and I hope you recognise the Pleiades, because not only do you have the graphical representation of the sky, but along with that, he also produced a star catalogue which gave the positions and brightnesses of every single one of these stars. And in the entire catalogue, there's about 250,000 stars. And he did that for each one. Now I don't want to be, a sort of a national stereotype kind of guy, but that is very German, isn't it? And basically how stars are named there is they are named in 1 degree bands. So here we've got, this is 20 degrees north, 21, 22, and so on. So any star that's north, that's basically between 20 degrees north and 21 degrees north, is going to be called BD plus 20 degrees and then some number. And the number will depend on how far east or west it is. Like all the previous surveys, you start at 0 degrees RA, which you can think of that as being the sort of Greenwich meridian of the sky. That's where you start measuring from, sort of lateral, not north and south, but round. So any star really in that 20 degree band, for instance, is going to be called BD plus 20 degrees something or other. For instance, if we look at Alcyone here, which is the brightest star of the Pleiades, its BD name is BD plus 23 degrees 541. It's the 541st star in this band. This is Taurus, so the band starts an awfully long way off to the right at 0 degrees. This is about sort of 4 hours RA instead of 0. So There's an awful lot of stars in this band before we get to this one. In fact, there's 540 before we get to this one, because that's number 541. Okay, that's a slightly complicated one, but it does enable you to find any star in that catalogue. And it goes 4 degrees south of the equator. He lived in Bonn. It's a fair way north, I suppose, so he didn't want to go too far south. But the far southern stars have been taken care of from Cordoba in Argentina, and they call that the CD. They're called the Cordoba Durchmusterung, mixing your languages there. And 100 years after that, we had the Smithsonian Astrophysical Observatory Catalogue, which I once had a copy of. Obviously, we don't really need them now because we've got all these wonderful planetarium programs. But the actual catalogue itself was in 4 very, very thick volumes, at least 2 inches thick, and page after page was taken up with nothing but the positions and details of each star. All of the stars in the BD, which is about 250,000 stars, plus about another extra 100,000. So that's an awful lot of stars catalogued to about magnitude 9.5 probably. So basically anything you can see in binoculars, good binoculars with a dark sky. And again, every single one of these stars had to be identified by a name or a number or something. So going back to Alcyone here in the Pleiades, its number in the SAO catalogue is 76,199. So an awful lot of stars. But again, the essential point is it enables you to identify a star. And you get other catalogues like the Henry Draper catalogue, which isn't a catalogue of stars' positions or brightnesses. It's a catalogue of star spectral types. But again, you have numbers in that catalogue. All of these modern catalogues run sort of sequentially. So the first star in the SAO catalogue is SAO 000001, and so on and so on. The SAO catalogue actually starts at the North Pole, and it runs in sort of 10-degree bands. So you have all the stars between 80 and 90 degrees north. Then in the next band, it's anything between 70 and 80 degrees north and so on. But that covers the entire sky, right down to the South Celestial Pole. And of course, now we have these huge catalogues. The Hubble Guide Star Catalogue consisted of, millions of stars, down to about magnitude 16, I think. And there, basically what they've done is they've divided the sky up into several thousand blocks. So in the Gaia star catalogue, again, every single star has, have to be identified, and obviously they're identified with numbers. So the first block gets the name GSC, Gaia star catalogue, then the number of the particular block, which as you can see runs to tens of thousands, and within each of those blocks, again, you have a certain sort of group of stars, which again runs into the tens of thousands. Very, very, very modern catalogues, such as Gaia. Gaia contains something like between 2 and 3 billion stars. And again, you have to name or number them all. So every single star in Gaia has an identifier. And as you can see here, the numbers are very, very long. This number actually came from a variable star sequence I was doing for I think it's a 19th magnitude star, because with CCDs, amateurs can now follow stars of magnitude 19 with not too much trouble. And that happened to have that identifier number. So if someone had a problem with it, I could go to the CDS in Strasbourg, which is held online, and I could put in that number, and that would bring up details of that particular star out of all those 2 or 3 billion stars. So it's the same thing. We are still identifying stars. Okay, we don't know the names, like, the yellow star in the charioteer's left shoulder, which was one way of identifying Capella, because that's kind of where it is in the picture version of the sky, if you like. But we're doing the same thing. We're still identifying every star that we need to identify. Yeah, so that's my 10 penneth, basically. So I'll stop sharing, and you can fire any questions that you may have.
Michael, thank you very much, sir. As always, wonderful to listen to you. Always loads of information as well. The Smithsonian Catalogue I find remarkably useful if I'm chasing comets.
Oh yes, yes,
because most hand controllers have that built in anyway.
Yes, I have the SAO catalogue.
So the SAO catalogue. So finding the nearest SAO entry when you're chasing comets and pointing at that is a very, very useful.
Oh yes, or following asteroids, anything like that.
Yeah,
yeah, and it's good because basically the SAO catalogue. It wasn't primarily to sort of list the brightnesses. It was really positional. So the positions in there are very, very accurate. The only problem is the positions are given for 1950. And obviously the stars have moved on a little bit since then. Yeah. Well, the stars haven't moved, it's the Earth's axis that's moved. But that means that the positions given there aren't quite as accurate. I once had a copy of the, it's a 4-volume set, in book form. But after it didn't become necessary anymore, because we have all these wonderful planetarium programs now. I ended up actually using them to prop the end of my bed up when I needed to elevate my leg for an injury. Poor old SAO, that was a very ignominious end for it.
Oh, fair enough. All right, ladies and gentlemen, I'm looking for questions. You're going to down at the club room. We're going to have to work this out as we go along. You're going to have to sort of put your hands up down there, and we'll get Roy to nominate somebody. I can see somebody waving down there. So digital hands, if you're with us digitally, would be helpful. Roy, if you've got somebody down there, then they can ask a question.
We have Phil waving his arms.
Okay, Phil.
Can you hear me, Michael?
Evening.
Yeah, good evening. Yes, when we were showing that catalogue of the list of stars, I noticed we were down to 7.6 magnitude, which I thought was quite impressive.
Sorry, what was that?
The magnitude of the catalogue as you were going down.
Oh yeah.
I noticed that they went down to 7.6 magnitude.
Something that needs to be borne in mind was not only were the constellation boundaries not sort of set in stone until about 1930, but various sort of famous observers had their own scales of magnitude as well. So the magnitudes weren't standardized either. Another one of the antiquarian books that this man actually gave me was a book called A Cycle of Celestial Objects by Admiral Smythe. And it was a really interesting book. But I think he wrote the book in about 1885. And he had his own scale of magnitude. So if Smythe said a certain star was magnitude 13, he might mention that William Herschel called it magnitude 16. So even the magnitudes weren't really sort of standardized properly. But yes, I know the one, the thing with all the stars in Aries, where he gives the magnitudes in the last column. So when he said magnitude 7 and 6, sorry, that's not a price in our money. He probably meant it was a double star, and they were the magnitudes of the members of the double star system.
Yeah, I've looked at variable stars, and I really struggled to estimate how brighter and dimmer they are. Yeah, I can see what's magnitude 2, 1, and 3, but to work out the variability, I really struggle with that.
It's just a question of practice, really. I mean, it's very, very simple in practice. Basically, what you do is you find your variable star, and you find one star in the field that's, you know, a bit brighter, and you find another star that's that looks a bit fainter than your variable star, and you just basically sort of place it in between the two. And when you know the magnitudes of those two stars, then you can work out how bright the variable, you know, appears to be. It's ever so easy, really. It's one of these things that's easier to do than it is to describe. Yeah, but trust me, you know, I mean, even I can do it. I think I've made about 45,000 variable star estimates. So, you know, I mean, if I can do it, anyone can do it. I'm just a simple old Norfolk boy.
Wow.
Switch cameras then. Oh,
I think you're very humble in that way, Michael.
Very humble, sir. Very humble.
Right. Have we got another question from down at the club room?
no, I think we're okay. Nobody's waving here.
Okay, I'm looking for digital hands for our online guests. And Bill from Cleethorpes. Good evening, Bill.
Hello, good evening. Yes, interesting talk and interesting to hear about all these different catalogues. Is there or have people set up catalogues of catalogues to go from one catalogue to another, or do you just? Because you know, I can imagine that you're using one catalogue and it's suiting you quite well, and then suddenly you find that catalogue doesn't have the next thing that you want to look in, so you've got to swap to another catalogue.
Well, there is actually I suppose you'd call it a sort of a repository for catalogues. Again, this is something that I use virtually every day. It's hosted at what's called the CDS, which is located at Strasbourg University, and that contains virtually every star catalogue that's ever been produced. Some of these catalogues actually reference other catalogues. For instance, the SAO catalogue also references the BD catalogue, you know, the big one. For a given star in the SAO catalogue, it will also tell you its BD name as well. But I mean, basically the place you want to go to if you want to look for a star catalogue is the CDS. That's easily available online. It's fairly regularly updated as well. There's very good catalogue which is called Panstarr. The Panstarr project was, I think, run from Haleakala, which is on Maui, another one of the Hawaiian Islands, and that shows stars down to about magnitude 21, and it gives you the accurate magnitudes of them as well. Everything you could possibly want to know about a star, its visual magnitude, its magnitude in infrared, its magnitude in the blue band, its position, everything. And that, again, that's a catalogue that I use a lot, because one of the things that I do is I also run the sequence team at AAVSO, and we produce lists of stars for people. This is amateur and professionals that need to study certain variable stars. In order to do that, you've got to have accurate magnitudes of stars to compare the variable with, and that's where Panstarr comes in very, very handy, because it gives you accurate magnitudes, and it also gives you a figure which tells you the reliability of how accurate the magnitude is as well. So yeah, basically everything you want to know about every star, but we're too frightened to ask. But the CDS at Strasbourg, I mean, it contains that catalogue. It contains Gaia with its 2-3 billion stars. It contains the old catalogues as well, like you can query the AAVSO, you can query the SAO catalogue. You can probably even query the original BD catalogue from about 1875. It's got catalogues of extragalactic objects, galaxies, nebulae, everything. Everything you can possibly think of. Asteroids, God knows what. Well, actually, probably God is the only person who does know what in this case, because everything's there.
Yeah, because you've also mentioned there you've got the question of, well, changing epochs all the time, and also proper motion.
Yes, that's another thing that the SAO catalogue got very accurately was the proper motions of stars. But of course, they're much more accurate now we've got Gaia. If you look at the SAO catalogue, it gives you, I think, the proper motions as they were known at the time, which is sort of mid 60s. Obviously, you know, they weren't using anything like the accuracy that we are now. And the proper motions were in sort of small fractions of a second of arc. Now we routinely give positions to sort of milli arc seconds to thousandths of an arc second, which is tiny, incredible accuracy. So, you know, again, Gaia has got all those. And that's how it's building up a sort of three-dimensional picture of the entire galaxy, because we know exactly where everything is, even though, of course, it's all moving.
Thank you.
Cheers.
And I'm looking around for any more questions. And I'm not seeing anybody. So, ladies and gentlemen, can we give a big Mexpert and Swinson?
Hang on, Paul. I think we've got to.
Oh, it's go.
Last minute substitution. He's warming up.
You know.
He dropped off.
Go on. I could never be an auctioneer, you know. I'd get to going twice, and there'd be always somebody there to interrupt me. Go on then, Mexpert, down at the club room.
No, we're just trying to wake John up.
Fair enough. Just trying to wake John Leach up. Fair enough. Ladies and gentlemen, can you give Michael Poxon a big Mexpert and Swinton Astronomical Society thank you for a brilliant talk? Thank you, Michael. And thank you for standing in at short notice.
No problem.
Thank you.